Hi, my name is David Stewart. I'm a sales engineer with JetBrains TeamCity, and today I'm going to walk you through 3 integrations to help you bring your CI to the next level. One of TeamCity's strengths is that we offer a lot of out-of-the-box functionality to help you integrate your CI into the other tools that make up your SDLC tool stack. So today what I want to do is focus on just 3 of those integrations specifically. What we'll do first is I'll give you a quick overview of the integrations we're going to talk about. So if you're watching the recording of this video, there'll be timestamps at the bottom. You can go ahead and just skip ahead to what interests you most. So taking a look, Cloud Profiles is going to be our first focus area. Cloud Profiles is an integration between TeamCity and your cloud computing environment. So that could be something like AWS, Azure, Google Cloud, Kubernetes, or some others. And basically what it allows you to do is spin up and scale your build agents in those environments on demand. So at a basic level, what's happening is a build gets triggered in TeamCity, and TeamCity is going to communicate with your configured cloud profile and spin up a build agent which can run in that environment. So these agents get set up in these cloud environments as AMIs or images or virtual machines, and TeamCity is going to handle the full licensing and lifecycle of that build agent. And what this can help prevent is a situation where your agents are sitting idle for hours at a time because they just can't run any of the builds that are sitting in the queue. And this can allow you to get some better utilization out of your existing licenses and also ease up on some of the management efforts that are required to manage, tens, hundreds, thousands of persistent agents. The second feature we're going to take a look at is integrating and embedding HTML third-party reports into TeamCity. We're going to do this without having to install third-party plugins or do custom coding. We're seeing that a lot of tools, including security scanning tools, testing tools, etc., they offer the ability to create these really rich HTML reports. And what we're going to do is we're going to embed those HTML reports into a TeamCity build tab so your teams can more easily review them alongside of the unit testing reports and a bunch of the other integrations that are already available inside the TeamCity UI. So we'll walk through a sample setup there. The last thing we're going to do is we're going to take a look at some of the available integrations between TeamCity and your IDE to do interesting things like running personal builds and also more mundane things like viewing the build status. So if you haven't installed the TeamCity plugins into your IntelliJ-based IDEs or Visual Studio or Eclipse, we'll show you how to do that and how to get up and running with that integration. So those are the core focus areas today, but as you probably know, TeamCity has a large number of integrations with other tools that make up your SDLC. So if you do have specific questions, please go to our website and get in touch with our team. We're happy to answer any questions you have. And with that, let's go ahead and get started with Cloud Profiles. So let's get down to basics. Cloud Profile is a collection of settings which allow TeamCity to start virtual machines or images in a cloud provider that can act as a TeamCity build agent. We support a number of different cloud providers, including AWS, Kubernetes, and VMware vSphere, which are all supported out of the box. And we also support Azure and Google Cloud. These are JetBrains developed and supported plugins, but you will have to download and install them from the JetBrains plugin marketplace. Cloud Profiles can be configured across your entire TeamCity instance, or you can configure Cloud Profiles at an individual project or sub-project level. So this gives your teams the ability to control which projects have access to which build resources. Before we talk through the configuration of a Cloud Profile, let's quickly review why a customer might use them and some of the benefits that they provide. From a licensing perspective, I know nothing is more frustrating than watching your build sit in a build queue while some other permanently connected agent sits idle that's not able to run your build. Cloud Profiles can streamline some of this licensing in TeamCity so that when a build is triggered, TeamCity is going to spin up an agent that you know has the appropriate requirements to run the build. It's going to license that build agent, and then importantly, it's also going to release that build agent license when the build finishes or under a set of parameters that you define. It costs money to keep these build agents alive, especially in a cloud environment. So TeamCity allows you to specify a number of termination conditions so that you can determine if you want those agents to be single use, shut off after a single build, or shut off after some sort of period of inactivity. And that's useful because I know we could all use a lower bill from our cloud providers. Another major benefit is that if you're using cloud profiles with AMIs or images for your build agents, instead of managing tens or hundreds of individual build agents, now you can only manage one agent image or maybe a handful of agent images if you have different requirements. So if you have software that needs to get updated, you only have to perform that task once. If you're already using build agents in other cloud providers like AWS and Azure, then using cloud profiles is really a no-brainer with TeamCity. So let's go ahead and take a look at how you actually configure them. Our first step is going to be to create an image based on the TeamCity build agent software that TeamCity is going to be able to connect to and create multiple VM instances of. I'm going to be running through this example in AWS, but functionally the process is going to be the same whether you're using AWS, Azure, Google Cloud. It will be a little bit different if you are running your build agents in a Kubernetes cluster, and that won't be covered in the video, but there is good documentation on our website for this use case. So our first step in AWS is to create a new instance which we're going to base our image on. You can create a cloud profile for any different OS or architecture type you need. And in fact, you may have different cloud profile images for your different development projects based on the building requirements for these projects. So I've gone ahead and I've already created an instance. The instance type isn't really important. What we want to do is we want to make sure that the TeamCity build agent software gets installed on this instance before we create the image. So if we go ahead and log in here, we can see that we've already installed the TeamCity build agent software. And importantly, you want to configure the build agent software so that it starts automatically. That way, when TeamCity is spawning a new instance of your build agent, it can connect to your TeamCity server and be ready to go to start building. Once we've created the TeamCity build agent instance, we're going to go ahead and we're going to create an image based off of that instance. You can do that through right-clicking on the instance name, going down to Image and Templates, and clicking Create the Image. This is what we're actually going to point to in TeamCity Cloud. There are some other intermediate steps for installing the build agent software, making sure it auto starts. All of that information is available in the documentation. Once you've configured the build agent images or AMIs that you want to use for your project, we can navigate back into TeamCity and configure the cloud profile. As I mentioned earlier, you can configure these cloud profiles across your entire TeamCity instance, or you can configure cloud profiles at an individual project or sub-project level, which is what we're going to go and do here today. So we're not going to navigate into our project and into our project settings, and then about 3/4 of the way down on the left-hand menu, you'll see an option for cloud profiles. We'll navigate into there, and we'll click Create New Profile. The first thing we want to do is select our cloud type. You'll see I have a few extra plugins installed in here, but we'll select Amazon EC2. We'll go ahead and give this a profile name, and now we can begin setting some of the termination conditions for how long we want these agents to live. The first thing we can set is the terminate instance idle time. This is going to default to 30. This is basically going to say if we see a build agent which was spun up with this cloud profile sitting idle for 30 minutes, go ahead and shut down that agent. We can also specify other termination conditions, for example, stopping after a certain amount of work time, or if you want these agents to be single use, spin them up, run the build, and kill them, you can go ahead and terminate the build agents after the first build completes. We'll go ahead and authenticate with our access key ID and our secret key, and we're also going to specify which region we want these build agents to be spun up in. You can specify limits for how many instances of these build agents a particular cloud profile can spin up. So if you need to control the resources that a specific project has based on how many build agents you have your license for, you can do that here as well. We'll go ahead and we'll check the connection, and then we can add our actual agent images. You can add multiple images for a single cloud profile, and I'll show you some of the settings you can specify here as well. So if we go ahead and we click on the Add Agent Image box, the first thing we're going to do is give it a name and a source. The source is going to be that AMI image that we created earlier, so we'll go ahead and select that. You can select all of your, these are Amazon specific settings here, your key pair name, your VPC subnet, your security group. And again, here you can set the max number of instances that this specific image is allowed to spin up inside this project. I will click on the advanced settings just to show you some of the additional features that are available. Some of the more interesting features for AWS specifically is we do allow you to use spot fleets or spot instances. If you're using just a regular image, you can use a spot instance. You can set the bid price for that specific image. Regardless, you will need to also specify the instance type, what size instance you want the agent to run on. And then if you want, you can also add these agents to a specific pool. So if you're already using agent pools to manage your build agents in an effective way, this is another way to just add those agents to a pool. So we'll go ahead and click Add, we'll click Save, and we're good to go. The last thing we'll do is we'll go ahead and run a build with our new cloud profile enabled. So if I navigate back to the project level, we will go ahead and just run a sample build of this pet clinic application. And then if we scroll up to the Agents tab, we can see that build agent spin up, get provisioned, get licensed by TeamCity, and then run the build. If we stuck around a little bit longer, we could also see the agent get terminated once it matched whatever termination conditions we set, and then that agent license would get returned back to the pool to be used by another cloud profile or for whatever else you need that agent license for in TeamCity. Next, let's focus in on how you can add third-party reports into your TeamCity instance seamlessly. So a lot of tools nowadays are generating these reports that we may want to see inside TeamCity without having to go to some other portal or some file directory somewhere. And the reports can come from just about any source, but we're frequently seeing customers integrate security scanning reports, reports from unit testing suites, visual regression testing reports, code coverage reports. There are really endless possibilities here. What's important is that your tools are able to generate an HTML report that could be one HTML page, a set of HTML files, and then we can bring those reports directly into a project or a build tab. There's no coding required. There's no plugins you need to install. This is all available out of the box. So there are three basic steps to this process. The first thing we need to do is we have to generate the report as a part of a build configuration. So this process is going to vary depending on the tools that you're using and the reports that you're trying to generate. In the example here, I'm going to be generating a code coverage report which gets run when we execute one of our Maven goals. But your tools may rely on some sort of command line call or some flag in your command line build steps. It could be an API call, or there may be some other way you're generating your reports. The important thing is that your build configuration generates the reports and is able to get pulled onto the TeamCity build agent. The second step is we need to make sure that TeamCity knows where to fetch this report, and the way we do that is by configuring an artifact path. So in our build configuration where the report gets generated, we're going to navigate into general settings, and then if you haven't already, you'll want to specify what that artifact path is. In our case, we have a target folder that gets generated. That's for all of our build artifacts. But it also includes our artifacts for the code coverage report. It gets generated in this site subdirectory. So you'll just want to make sure that at least the high-level directory folder here is specified. Once we've done that, we can navigate back up into the project settings, and the third tab down on your project settings is going to be this reports tab. Here we have two options. We can generate reports, a report tab that's going to appear at the project level, or we can generate a report that's going to appear at an individual build configuration level. So this is just determining where you want that tab to exist. We'll go ahead and create one at the project level. We'll give this new tab a title, and then we're going to tell TeamCity where we're fetching that artifact from. So that's going to be which project and build configuration are we getting the project from, and then importantly, which version of that artifact do we want to display. We can select something like the last successful build. You may want to choose the last pinned build, or you can be much more specific. If you have builds that run and get a tag added, you can run a build and grab the report with a specific tag. We'll go ahead and use last successful here. We can also specify a branch filter. So you may not want to have a code coverage report displayed for anything other than your main branch. You want all of the other development branches. You don't need to see the individual code coverage reports there. That sort of behavior is up to you. You can use the little magic arrow icon to show you all the different branches that are available for that build configuration. The last thing we're going to do is specify the start page. Because it's an HTML report, we just need to put the start page here. Even if your report is generating a bunch of different HTML pages, that's fine. All we're doing is we're going to point to where the start page for, in this case, the code coverage report exists. So we'll come into the target, into the site folder, and we'll select index.html. It'll change the path, and we're good to go. We can go ahead and click Save. So if we go ahead and run a new build, we can now see this custom tab inside of our project level. So we'll go to Spring Pet Clinic, and then here you can see, yes, we have our new custom tab, which is displaying our code coverage report. This is fully navigable. You can click in and out, move between the different aspects of the HTML report. Let me show you a couple of other interesting ways we're using this internally here at JetBrains. I'm going to go to our public TeamCity.JetBrains server, and we're going to take a look at the Ring UI project, which is just a collection of our UI components that developers can use if they're developing third-party plugins, and then we obviously use it internally as well. One component of the Ring UI is we generate a storybook, which is a large HTML page where you can interact with the different UI components. And we actually display a copy of this storybook inside of the TeamCity UI. So when a build runs, if we want to see if anything got generated that looks a little bit weird, we can do that directly inside of the UI at the project level here. A more interesting use case is our visual regression testing. We use a testing suite called Hermione to run our visual regression tests. And then as a part of that visual regression testing, we have a custom report in our build configuration tab that's going to output the full Hermione visual regression testing report here. Much like the code coverage report, you can interact with this. You can view the skip tests, the failed tests, etc. It's up to you how you want to display the results in here. So just two interesting use cases. If you have your own interesting use cases, we'd love to hear about them. Please feel free to get in touch with us, share it, and we'd like to see how we can improve here. The last thing we're going to look at today is TeamCity's various integrations with IDEs. TeamCity supports IDE plugins for most of the IntelliJ platform based IDEs from JetBrains, so that includes IntelliJ, PyCharm, WebStorm, Rider, and the others. We also develop and support plugins for Eclipse and Visual Studio. The first thing we need to do is install the plugin into our IDEs. For IntelliJ-based plugins, you can do this from plugins.jetbrains.com. Just search for TeamCity, and then from the TeamCity plugin page, there's actually a one-click install in the top right corner. It'll open up a dialog inside of your TeamCity IDE, which will allow you to install the plugin. It may require an IDE restart, just as a heads up. Once the plugin is installed, it's going to add a new menu bar at the top here for TeamCity. We're going to go ahead and log in to our TeamCity instance. So go ahead and give it the URL, specify your password and username, and click OK. And once you log into the IDE plugin for the first time, I recommend you configure your visibility and notification settings by clicking this Configure Shown Projects icon on the left-hand side. That's going to open up TeamCity in a tab in your browser, and you're actually inside of your TeamCity profile right now. So from here, you can configure things like your notification rules and your visibility settings. You can see I have a notification rule already configured in here. Basically, this is just showing projects and build configurations related to Spring Pet Clinic, and then I am letting the IntelliJ IDE show in IDE notifications when a build fails or a build is successful for this specific project. So let's take a look at some of the things you can do inside of the TeamCity plugin. Some basic functionalities are available in here. You can view your projects, the build configurations for those projects, and the latest status. You can see if the tests have passed, if the tests have failed. You can also view the build data directly in the IDE for things like the build log. One of the more powerful features of these IDE plugins is they allow you to execute a remote run or a personal build of your changes in your IDE. So let's say you're making some changes to your code base. You may not necessarily want to commit them to the code base yet, where a regular build would be run. What we allow you to do is execute these remote runs. These are personal builds that happen on the TeamCity server and build agents, but they're only going to be visible to you. So you can run your builds, your changes in peace without other folks eyeing and seeing what's going on. If you select the remote run feature, it's going to show you a list of the changes that exist in your workspace right now. You can specify a commit message. This is just going to be shown in TeamCity. We're not actually committing any source code here, but we are notifying TeamCity what the changes are that are about to be run on this personal build. We'll go ahead and click Remote Run in TeamCity, and we're going to be given the option to select which build configuration we want to run for this project. It's automatically identifying the various configurations that may be suitable here. I use this Pet Clinic application a lot, so I have a few demo configurations that I could also select to run this on. We'll go ahead and click OK, and then if we navigate back to TeamCity, you'll see something interesting on the projects page for Pet Clinic. You'll see the regular builds that we've run in the past from our cloud profiles or from our other build runs, but you will also see a new icon for the running build with this little person icon. This is your personal build. So anything that happens here is only going to be visible to you. Only you can view the changes, the passed or failed tests, etc. So let's give this a minute to finish running. Okay, through the magic of video editing, our personal build has finished, and it looks like we have a build failure. We see the little notification in the bottom right-hand corner. We can go ahead and view the full build configuration run inside the browser, that's going to pull up the personal build, and you can navigate through this the same way you would a regular build in TeamCity. But we can also view the details of this build failure inside of the IDE. In this case, we had 2 tests that failed. We can navigate through these tests, try to figure out why they failed. And another interesting feature here is if we right-click on these tests, we can run these tests locally because they're integrated with JUnit. So TeamCity is able to detect them, and we could just run these tests locally without having to run the full test suite back in TeamCity. So some more nifty features for the IDE integrations. TeamCity IDE plugins also enable you to execute pre-tested commit or delayed commit workflows. In a pre-tested commit workflow, you submit your code changes to be executed via TeamCity remote run before the code actually gets committed. So if your change is passed and you have a green build with that remote run, your changes are automatically committed to your version control system. With this type of workflow, broken code never enters your version control system, which can be a huge advantage for some development teams. There's some limitations depending on the IDE you're using and which version control system you're using. So check out the documentation on pre-tested commits if you're interested in learning more. So that's it for me. If you have any questions about what you've seen here today, definitely feel free to get in touch with us via our website. There's a lot more to discover. TeamCity offers a huge number of integrations with other tools that make up your SDLC tool stack. So here's to lots of green builds and happy building.